This will be the last section in the 4.7 notes, and what's going to differentiate these from the other sections is you'll be given algebraic expressions for the sides of the triangle instead of set numbers like square root of 3 over 2. You're going to have something like 1 over x. The first thing you should do on these is draw a triangle based on the expression that you're given for the function inside parentheses. So for example, if they say you have 2x, don't forget that that's 2x divided by 1. So if it's the sine function, you know that the opposite side is 2x and the hypotenuse is 1. You should be able to fill in two sides of the triangle even if you just have one expression like 2x. Next, you're going to find the third side using the Pythagorean theorem the way we've been doing in the other sections. And then finally, you'll write the fraction of the exterior function, the one that's on the farthest side outside of the parentheses, using the opposite, adjacent, and hypotenuse rules, the same way we have with sine being opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for this example, I'm focusing just on what's inside the parentheses first, and they say sine inverse of x, but you might want to think of that as x over 1. So the rule for sine is opposite and hypotenuse, and I'm always going to draw a first quadrant triangle for these. So in this case, if I have theta in this bottom left corner, the side opposite will be the x, the hypotenuse will be the 1, and then when I go to write x squared plus, and it doesn't matter what I use for the second side of the triangle, in this case I'll treat it as b squared, is equal to 1 squared. So now I need to solve for that missing side, which in this case is b squared. So I'm going to write b squared is equal to 1 minus x squared. And the last thing we have to figure out is for the side itself, that's going to be the square root of this. So I still need to get b by itself. Usually that would create a positive and a negative answer, but we're going to ignore the negative one because all the negatives do with our triangles is indicate direction, but we're setting this as a positive value if we put it in the first quadrant anyways. So my missing side will be the square root of 1 minus x squared. So you should get some kind of an expression written in based on the other variable that you already have. Now that I have all three sides of the triangle, that was done from what was inside parentheses. Now I'm going to look at the next piece outside the parentheses to figure out what my final answer will be. So with all three sides of the triangle filled in, I can say that cosine of theta is equal to adjacent over hypotenuse. And dividing by 1 is not going to change anything for my answer. So my answer is just going to be the square root of 1 minus x squared in this case. So to summarize what we did, we used the information inside the parentheses to set up our triangle to fill in two of the sides. We used Pythagorean theorem to find the third missing side. Then we looked at the function outside of the parentheses to say what's the relationship between the sides of the triangle that determine our final answer. So for cosine, adjacent over hypotenuse. Here's another similar example. Again, I'm going to focus on what's inside parentheses first to draw my triangle. And don't forget that even though they just said tangent inverse of 2x, I'm actually going to think of that as 2x over 1, so that I actually have two sides of my triangle given here. So if this is a first quadrant triangle, then theta is in the bottom left corner and my right angle is here. The rule for tangent is opposite over adjacent. So the opposite side is 2x. The adjacent side is 1. And then when I go to write the Pythagorean theorem, I'll have 1 squared plus, be careful about putting this in parentheses, 2x squared. Both 2 and the x are being squared. If you don't use parentheses, then you're only squaring the x. And that's going to equal the hypotenuse. I'm going to call it c squared as if I'm using the traditional a squared plus b squared equals c squared setup. So c squared is what I'm missing, which means all I need to do is clean up and simplify this a little bit on the left-hand side. So 2x times 2x is 4x squared plus 1. And then since this isn't just c, it's actually c squared, I'm going to take the square root of both sides. And again, in this case, I'm able to ignore the negative answer and just write that this is square root of 4x squared plus 1. I don't have to worry about the negative version of that answer as well. The only reason I would be using the negative 1 would be if I had a triangle that was going in a different direction, but the hypotenuse can never be negative anyways. But if it was going down, then you might want to consider using a negative value for that side, but that shouldn't happen on these. So the third side of my triangle is the square root of 4x squared plus 1 Now I can look at the relationship outside the parentheses. Secant is the reciprocal of cosine, which means instead of doing adjacent, the adjacent side over hypotenuse, you're going to be doing hypotenuse over adjacent. So my final answer is going to be square root of 4x squared plus 1, because dividing by 1 again does not affect anything in my answer. For our last example, we do have a fraction inside, but this isn't going to complicate very much for us actually. I'm still going to draw a first quadrant triangle with theta in the bottom left, right angle in the bottom right. The rule for cosine is adjacent over hypotenuse. So my adjacent side is the one next to theta. Hypotenuse is across from the right angle. And by setting up Pythagorean theorem, I have 1 squared plus b squared equals x squared. Now this side, the b side, is what I'm actually missing. So if I subtract 1 from both sides, and then take the square root, again ignoring the negative version of the answer, then we now know the missing height of the triangle, which is the square root of x squared minus 1. So now that we have used the inside of the parentheses, the interior function, to set up our triangle and find the missing side, now I can use the exterior function to find what our final answer is, the relationship defined by this function. So the rule for sine is opposite over hypotenuse. So this one's a little bit more complicated than the other answers, which just ended up being over 1. But there's nothing I can actually do to simplify this particular answer. You should always check to see if there's any simplifying or rationalizing that can be done, but I don't have a radical in the denominator, and I don't see any way to cancel or break things out of this. So that's all for the notes today. Thank you.